99% of Toyota hybrid owners pour whatever oil is cheapest into their crankcase and never think twice about it. But we wanted a real answer, not a forum opinion, not a dealership guess. So we took two identical Toyota RAV4 hybrids, same trim, same 2.5-liter dynamic force engine, same mileage at the start, same driving routes, same drivers rotating weekly, so no single habit could skew the results. One ran on Toyota's factory recommended 0W-16 synthetic oil for a full year. The other ran on 5W-30, the older, thicker viscosity that most people still associate with real engine protection. We tracked fuel economy, cold start behavior, oil pressure readings, engine noise, and we pulled oil samples for analysis at 3, 6, 9, and 12 months. What we found surprised even us, and by the end of this video, you will know exactly which oil actually belongs in your Toyota hybrid and why the difference is bigger than most people realize. Let's start with why this comparison even matters. Toyota's newer hybrid engines, the kind found in the RAV4 hybrid, Camry hybrid, Corolla hybrid, and Highlander hybrid, were engineered around ultra-thin 0W-16 oil. This isn't a marketing gimmick. The oil passages, the clearances between the crankshaft and the main bearings, the tolerances inside the variable valve timing actuators, all of it was designed around a thinner film of oil moving faster through the system. Toyota did this for one primary reason: friction reduction. A thinner oil moves with less resistance, which means the oil pump works less. The piston rings glide with less drag, and the engine spends less energy just moving its own internal parts. That translates directly into better fuel economy, which matters even more in a hybrid where every fraction of efficiency stacks on top of the electric motor's contribution. 5W-30, on the other hand, was the standard for decades across almost every Toyota engine, hybrid or not. It is thicker at operating temperature. It creates a slightly stronger film between metal surfaces under heavy load, and it is still listed as an acceptable alternative in some Toyota owners' manuals, particularly for regions with sustained high heat or for engines under heavier stress like towing. So the real question was not which oil is better in a vacuum. It was which oil is actually better for a hybrid engine that was purpose-built around a specific viscosity. The first thing we noticed had nothing to do with long-term wear. It showed up in the first week during cold starts. The RAV4 hybrid running 0W-16 fired up noticeably quieter on cold mornings. Toyota's hybrid system already shuts the gasoline engine off frequently at low speeds and during braking, so the engine is constantly restarting throughout a normal drive, not just once in the morning. Every one of those restarts depends on oil reaching the camshaft, the hydraulic lifters, and the timing chain tensioner as quickly as possible. Thinner oil flows faster at low temperatures, which means the 0W-16 vehicle had oil pressure established measurably sooner after each restart. The 5W-30 vehicle wasn't dangerously underprotected, but you could hear a faint extra half-second of mechanical clatter on cold mornings before the engine settled into its normal rhythm. Over a single day, that means nothing. Over a year of dozens of stop-start cycles per drive, that gap in protection timing adds up. Fuel economy was the next area where the difference became obvious, and honestly, this is where most owners will care the most. Averaged across the full year, the RAV4 hybrid running 0W-16 consistently returned better miles per gallon than its 5W-30 counterpart, with the gap being small on any single tank, but adding up to a noticeable percentage difference by the time we tallied 12 months of fuel logs. This lines up with what Toyota engineers have said publicly for years, that the shift toward ultra-low viscosity oils across the industry exists specifically to shave fractions of a percent off fuel consumption. And in a hybrid where the electric motor already carries a big share of the workload, that fractional gain from the oil becomes a larger relative percentage of the total efficiency picture. The 5W-30 engine wasn't inefficient by any stretch, but it was working slightly harder to push a thicker fluid through the same oil pump, the same narrow galleries feeding the cylinder head, and the same tight clearances around the crankshaft journals. Now here's where things get interesting, because thinner isn't automatically better in every scenario, and we wanted to stress test that assumption instead of just assuming Toyota's spec sheet settles the argument. Midway through summer, we intentionally drove both vehicles in extended high heat conditions, sitting in traffic with the air conditioning underload, engine bay temperatures climbing well above normal. This is the scenario where 5W-30's thicker film theoretically holds an advantage, because a thicker oil resists thinning out under extreme heat better than an ultra-low viscosity oil does. When we pulled oil samples after those high heat sessions, the 5W-30 did show a slightly more stable viscosity index under sustained thermal load. But the 0W-16, while it did thin out marginally more than the thicker oil, stayed within its designed operating range the entire time. Toyota's hybrid engines are engineered with that heat behavior already accounted for, meaning the thinning that occurs is expected and doesn't push the oil outside safe protective limits under normal driving, even aggressive summer driving. The 5W-30 wasn't providing meaningful extra protection in this case. It was simply behaving the way a thicker oil behaves, without translating into better outcomes for an engine that wasn't designed around it. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. The oil analysis reports gave us the clearest picture of what was actually happening inside each engine, and this is the part most YouTube comparisons skip entirely. At the 6-month mark, both vehicles showed normal wear metal levels for their mileage, nothing alarming in either case. But by the 9-month mark, small differences started to separate. The 5W-30 vehicle showed a slightly elevated presence of aluminum, which typically traces back to piston skirt wear or wear inside the aluminum engine block itself. Nothing dangerous, nothing close to a failure threshold, but higher than the 0W-16 vehicle's corresponding sample. Our working theory, supported by conversations with independent oil analysis technicians, is that the thicker 5W-30 doesn't flow through the narrow oil control rings and piston ring lands on this specific engine design quite as efficiently as the viscosity it was actually engineered around. It's not that 5W-30 is a bad oil, it's that it's slightly mismatched to tolerances that were machined with a thinner fluid in mind. The 12-month final samples told a similar story. The 0W-16 engine's wear metal stayed remarkably flat across the entire year, with only the expected gradual mileage-related increase. The 5W-30 engine's wear metals were still within Toyota's acceptable range, but the trend line was climbing slightly faster. Again, we want to be clear. This is not a story about an oil that destroys an engine. Both vehicles ran perfectly fine all year with no drivability issues, no warning lights, no noticeable performance loss. This is a story about which oil is optimized for this specific engineering, and the data leaned firmly in one direction. Noise and vibration told a similar tale. Around the 9-month point, the 5W-30 vehicle developed a very faint, almost imperceptible timing chain hum during initial cold starts that wasn't present in the 0W-16 vehicle. This lines up with something Toyota technicians have flagged before, that hydraulic timing chain tensioners on newer dynamic force engines are calibrated for a specific oil pressure delivery curve, and thicker oil arriving slightly slower on cold starts can create momentary slack in the chain before full pressure builds. Again, not a failure, not a warranty issue, just a subtle behavioral difference that most owners would never notice unless they were specifically listening for it, which we were. We also tracked oil consumption between changes, since burning oil is one of the clearest signs of ring seal quality and overall internal wear. The 0W-16 vehicle consumed slightly less oil across the year between service intervals. Thinner oil generally has a small natural consumption disadvantage in older engine designs because it can slip past piston rings more easily. But on an engine specifically engineered around it, the piston rings and cylinder walls are machined to seal properly at that lower viscosity, which is likely why we saw the opposite result here. The 5W-30 vehicle burned marginally more oil, which tracks with the slightly elevated wear metals we found in the analysis, since piston rings that aren't sealing quite as tightly against the cylinder wall will both burn a touch more oil and allow slightly more metal-on-metal contact during operation. There's also the matter of what happens under the hood that most drivers never think about: the oil pump itself. Toyota's oil pump on this engine is calibrated to move a specific volume of fluid at a specific pressure to feed the crankshaft main bearings, the connecting rod bearings, the camshaft journals, and the variable valve timing solenoids that adjust intake and exhaust timing on the fly. When you run a thicker oil through a pump calibrated for a thinner one, the pump has to work slightly harder to push that fluid through the same passages, and that added resistance is where you lose some of the fuel economy we already talked about. It's a small mechanical tax, but it's a real one, and it's baked into every single mile the 5W-30 vehicle drove that year. One area where the 5W-30 vehicle genuinely held its own was under sustained highway towing simulation, which we ran periodically using a small trailer to load the engine beyond typical daily driving. Under that kind of sustained load and heat, the thicker oil's film strength gave it a marginal edge in maintaining consistent oil pressure. This matches what Toyota itself notes in some regions, recommending 5W-30 as an alternative specifically for vehicles used in severe duty conditions like heavy towing or extreme heat climates. But for a hybrid RAV4 used the way the overwhelming majority of owners actually use it, daily commuting, stop-and-go traffic, occasional highway trips, and normal weather variation, that towing scenario represents a small sliver of real-world use, not the everyday baseline. So after 12 months, thousands of logged miles, 4 rounds of laboratory oil analysis, and dozens of hours listening to and comparing cold starts, the results point to a clear winner for the way most Toyota hybrid owners actually drive. The 0W-16 oil delivered better fuel economy across the entire year, faster oil pressure delivery on cold starts, lower wear metal trends in laboratory analysis, quieter timing chain behavior, and lower oil consumption between changes. The 5W-30 wasn't a disaster by any measure. and it showed a real, measurable advantage in extreme heat and heavy load scenarios. But for the everyday hybrid owner commuting to work, running errands, and occasionally hitting the highway, the engine simply performs better on the oil it was actually engineered around. The bigger lesson here isn't really about brand loyalty to a specific viscosity. It's about understanding that modern engines, especially hybrid engines juggling constant engine shutoffs and restarts, are precision machined around a specific fluid behavior. Toyota didn't pick 0W-16 arbitrarily. Engineers calculated exact clearances between the crankshaft and its bearings, the exact flow rate needed through the cylinder head to feed the camshaft and the variable valve timing actuators, and the exact pressure curve the oil pump needs to hit on a cold start when the gasoline engine is firing up for the 10th time that hour, because the hybrid system just switched from electric power back to combustion. Deviating from that spec doesn't destroy your engine overnight, as our year of testing clearly showed, but it does mean you're asking components to perform slightly outside the conditions they were precisely designed for, and over years and tens of thousands of miles, that gap compounds into exactly the kind of small but measurable differences we tracked in this test. If you drive a Toyota hybrid and you've been putting 5W-30 in it because that's what you've always used, or because a shop defaulted to it without checking your owner's manual, this is the sign to switch back to what Toyota actually specifies for your engine. The oil pressure, the fuel economy, and the long-term wear numbers all point the same direction, and it costs you nothing extra to use the oil your engine was literally built around. If you are enjoying this video, consider watching this one where I am sharing the maintenance mistakes that quietly kill Toyota hybrid batteries years before they should fail.